According to the 2023 National Electrical Code, the minimum wire sizes for a sub-panel fed from a house are as follows. Firstly, the ungrounded conductors or hot wires should be 1/0 American wire gauge. Secondly, the neutral conductor should be number 1 American wire gauge. And thirdly, the grounding conductor must be the same size as the ungrounded conductors or larger. These wire sizes are based on a maximum allowable voltage drop of 3%. If a larger voltage drop is acceptable, larger wire sizes may be used. It is important to consult with a qualified electrician to determine the appropriate wire sizes for your specific application. When determining the correct wire size for electrical installations, several factors must be considered to ensure safety and compliance with the National Electrical Code or NEC. Firstly, the ampacity of the wire is a critical factor. Ampacity refers to the maximum amount of current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables, such as Table 310.16, that list the ampacity of various wire sizes based on their insulation type and installation conditions. Secondly, voltage drop is another important consideration. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use Ohm's law and the wire's resistance per unit length. Thirdly, the type of insulation used on the wire affects its ampacity and suitability for different environments. Common insulation types include THHN, THWN, and XHHW. Each type has different temperature ratings and resistance to moisture, heat, and chemicals. The NEC specifies the appropriate insulation types for various applications. Fourthly, the installation method of the wire also influences its ampacity. Wires installed in conduit or buried underground have different ampacities than wires installed in free air. The NEC provides adjustment factors to account for these different installation conditions. For example, when multiple current-carrying conductors are installed in the same conduit, their ampacity must be derated to prevent overheating. Fifthly, the ambient temperature surrounding the wire affects its ampacity. Higher ambient temperatures reduce the wire's ability to dissipate heat, which lowers its ampacity. The NEC provides correction factors to adjust the ampacity based on the ambient temperature. Sixthly, the type of load being served by the wire must be considered. Continuous loads, such as lighting and heating, are defined as loads that operate for 3 hours or more at a time. The NEC requires that the overcurrent protection device, such as a circuit breaker or fuse, be sized no less than 125% of the continuous load. This means that the wire must be sized to carry at least 125% of the continuous load. Seventhly, the length of the wire run affects the voltage drop. Longer wire runs result in greater voltage drop. To minimize voltage drop, you may need to increase the wire size or use a higher voltage system. Eighthly, the number of conductors in a raceway or cable affects the ampacity of the conductors. When multiple current-carrying conductors are installed in the same raceway or cable, their ampacity must be derated according to NEC Table 310.15 cone. Ninthly, the terminal temperature rating of the equipment being connected to the wire must be considered. Equipment is typically marked with a terminal temperature rating such as 60 degrees Celsius or 75 degrees Celsius. The wire must be sized so that its ampacity at the terminal temperature rating is sufficient to carry the load. Tenthly, the presence of harmonics in the electrical system can affect the wire size. Harmonics are currents and voltages that are multiples of the fundamental frequency of the system. Harmonics can cause overheating of conductors and equipment. If harmonics are present, you may need to increase the wire size or use a neutral conductor that is sized larger than the phase conductors. To determine the correct wire size for a specific application, it is essential to follow a systematic approach. Firstly, determine the load current that the wire will be carrying. This can be calculated using Ohm's law or obtained from the equipment nameplate. Secondly, determine the ambient temperature and insulation conditions. This will help you select the appropriate insulation type and apply any necessary correction or adjustment factors. Thirdly, calculate the voltage drop for the wire run. If the voltage drop exceeds the recommended limits, increase the wire size or use a higher voltage system. Fourthly, select a wire size that has an ampacity equal to or greater than the load current, taking into account any correction or adjustment factors. Fifthly, ensure that the wire size is compatible with the terminal temperature rating of the equipment being connected to it. Sixthly, verify that the wire size complies with all applicable NEC requirements and local codes. In the specific case of feeding a sub-panel from our house, the NEC provides specific requirements for the wire sizes. The ungrounded conductors, also known as hot wires, are typically sized based on the load that the sub-panel will be serving. The neutral conductor is typically sized based on the unbalanced load, which is the difference between the current flowing in the phase conductors. The grounding conductor must be sized according to NEC Table 250.122, which is based on the size of the overcurrent protection device protecting the circuit. It is important to note that the NEC is a minimum standard, and it may be necessary to use larger wire sizes to meet specific application requirements or to minimize voltage drop. Consulting with a qualified electrician is always recommended to ensure that the wire sizes are appropriate for the specific application. Additional considerations may include the use of aluminum conductors instead of copper conductors. Aluminum conductors have a lower ampacity than copper conductors of the same size, so they must be sized larger. The NEC provides tables that list the ampacity of aluminum conductors. Also, the type of overcurrent protection device used, such as a circuit breaker or fuse, can affect the wire size. Circuit breakers and fuses have different interrupting ratings, which is the maximum amount of current that they can safely interrupt. The wire must be sized so that it can withstand the available fault current at the point of installation. Furthermore, the coordination of overcurrent protection devices is important to ensure that the circuit breaker or fuse closest to the fault will trip first, minimizing the extent of the outage. Wire sizing calculations can be complex, and it is essential to have a thorough understanding of the NEC and electrical principles. Using the wrong wire size can result in overheating, equipment damage, and even fire. Therefore, it is always recommended to consult with a qualified electrician to ensure that the wire sizes are appropriate for the specific application. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Remember, safety is paramount when working with electricity. Always to energize circuits before working on them and use appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. The 2023 NEC contains several changes that may affect wire sizing calculations. Be sure to review the latest edition of the NEC before performing any electrical work. Also be aware that local codes may have additional requirements that are not covered by the NEC. Check with your local building department to ensure that your electrical installation complies with all applicable codes. Proper wire sizing is essential for the safe and reliable operation of electrical systems. By following the NEC requirements and consulting with a qualified electrician, you can ensure that your electrical installation is safe and code compliant. In summary, determining the correct wire size involves considering ampacity, voltage drop, insulation type, installation method, ambient temperature, load type, wire length, number of conductors, terminal temperature rating, and the presence of harmonics. A systematic approach, along with consulting the NEC and a qualified electrician, is crucial for ensuring a safe and compliant electrical installation. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are unsure about any aspect of wire sizing or electrical installation, consult with a qualified electrician. They can provide you with expert advice and ensure that your electrical system is safe and reliable. Finally, remember that electrical codes and regulations are constantly evolving. Stay informed about the latest changes and updates to ensure that your electrical work is always up to code. By following these guidelines, you can help to ensure the safety and reliability of your electrical system.